Alright, we're going to talk about product rule, and then in the next video we're going to talk about quotient rule. So product rule happens when I have two functions that I can't simplify, can't FOIL, can't multiply through. I'm just kind of stuck with them. And so I have two functions, let's say an f of x and a g of x, that I'm multiplying together. And so I'm going to call the first function f for first, and the second function I'm going to call s for second. Then the derivative of the products, so essentially what we're talking about is the derivative is going to be the derivative of the first times the second plus the first times the derivative of the second. So fs. So what's happening is, if you notice, your little prime here is changing from the f on the first guy, and he goes to the s on the second guy. So if you want to write the derivative of the first times the derivative of the second plus the derivative of the first times the second, that's kind of what's going on here. And so let's go ahead and hop in several examples. As you notice, I hope you notice that I have my two functions. My first function is 6x. My second function is sine x. And so I want to think about what is the derivative of the first, and I'm going to multiply by the second, and then add to of the first times the derivative of the second. So here we go. So we have y prime. We have y prime is equal to, so we're going to do the derivative of the first. I'm going to keep on color coding. This is 6 times my second. I'm not taking the derivative. I'm just leaving them as it is. And I'm going to add that to the first times the derivative of the second. Derivative, again, of sine is cosine of x. All right, let's look at another example. All right, in this case, my first is that negative 2 cosine x. My second is this massive polynomial that you see here. And so again, I'm going to take my derivative. So my derivative of the first is going to be equal to, so again, I'm going to keep my 2, my negative 2, but the derivative of cosine is negative sine. So my negative 2 now, because I'm talking about negative sine, I'm just going to make that a plus. And so this becomes 2 sine x. That's the derivative of my first. I'm going to multiply it by my second, which is 3x to the third minus 5x plus 7. And I'm going to add that to my first, which is that negative 2 cosine x. And I'm going to multiply that by the derivative of the second. So the derivative of the second is going to give me 9x squared minus 5, and I am finished. So here's trying to keep it color-coded for you so you can see how the product rule really works. In the table below, Rx and Tx are differentiable functions. Find the equations for the line tangent to Q at x equals negative 3 if Q is equal to Rx Tx. So in this case, they don't give you a function. What they give you instead is a table. They kind of do the values for you. So that they're trying to see, can you track the table? And so my first function is r of x. That's this guy right here, r of x. That's my first function. His derivative is found over here. My second function is tx. He is found here. His derivative is found over here. So I'm going to keep the same type of pattern. Remember, our pattern is y prime is equal to the derivative of the first, that's what that little tick mark goes, times the second, added to the first, times the derivative of the second. And so in this case, the s is going to have the tick mark. All right, so our y prime, if you noticed, our first is this negative 4, so I'm going to write negative 4. Okay, so it would help if I had my equal sign here. And I'm going to, whoops, I totally messed it up, guys. Sorry about that. It's not going to be negative 4. That's supposed to be my derivative. My derivative is found over here. Sorry about that. So I have y prime is equal to negative 2 times my s, and so regular s is found here. There's my positive 2. And I'm going to add that to my first, which is my negative 4 here, times the derivative of my second, which is found all the way over here. And when I simplify, I get negative 4 minus 12 is equal to negative 16. Finally, number 4, find the values of x for where x is between 0 and 2 pi, where the tangent line to the graph of y equals sine x cosine x is horizontal. So we're going to go ahead and once again, here is my first sine x. My second is cosine x. And so I'm going to go ahead and use my derivative rules. Y prime, so here's my product rule. Derivative of the first is cosine x times the second, which is cosine x, added to the first, which is sine x. Whoops, wrong color. Sine x times the derivative of cosine, which is negative sine x. So if I was going to simplify this, essentially what I have is y prime is equal to cosine squared, because there's two of them, minus sine squared. Well, I'm going to just set that equal to 0 because a horizontal line has a slope of 0. And I'm just going to move sine squared to the other side. So we're talking about where cosine squared x is equal to sine squared x. And if you want to, you can kind of take the square root of both sides. I'm not going to worry about plus or minus because I'm going to consider both times where cosine is equal to sine. So if you want to think about your unit circle, in what two quadrants are both sine and cosine have the same sign? If you notice, in the first quadrant, they're both positive. In the third quadrant, they're both negative. And so where, at what angle does cosine equal sine? Well, that would be at a 45-degree angle, both in the first quadrant and third quadrant. So we're talking about pi over 4. And this is my first pi over 4, second pi over 4, third pi over 4, fourth pi over 4. Here's my fifth pi over 4. And so x would be equal to pi over 4 and 5 pi over 4.